Alright, so this is number 12 on the test review. Question, or the information they gave you on it was that the scores on a test are normally distributed with a mean of 81 and a standard deviation of 6. And then the question I asked was what percent of scores are higher than 87. Since it's normally distributed, we want to draw out that bell-shaped curve. Looks something like that, maybe a little bit better than that. It's a little bit better. Not the best, but close enough. Mean is your center, right? So say this is the middle of the graph, that would be 81. In order for me to figure out what percent of scores are higher than 87, I kind of need to know where the heck 87 even is on this graph. You know, how many standard deviations away it is and that sort of thing. So since I know my standard deviation is 6, I'm just going to start adding 6 and subtracting 6 to both sides until I get to 87. Doesn't take that long because 81 plus 6 is 87, so one standard deviation away I find my 87. 81 minus 6 in the other direction then would be 75. Now if I want to graph out further, if I want to take 87 plus 6 and mark the 93 and such, I can, but I don't need to because I've already found the 87 and I'm only trying to answer the question that I was asked. It wants the percent of scores that are higher than 87, meaning from 87 to the right. What percent of scores is that? Okay, well, we know from the empirical rule that 68% of our data is within one standard deviation from the mean. So that means from here to here is 68%. Well, none of that is the stuff greater than 87. So I can already tell you that 68% of our data is not going to be involved in this question. This is statistics. We're talking a real life situation. 100% is the highest that we can have. So 100 minus 68 tells me I only have 32% left. So I can tell you right now my answer is going to be 32% or less of the scores are higher than 87, because I've already proven right here that 68% can't be a part of it. Now it's obviously less than 32% because we've got all of this area over here and all of this area over here that we still haven't accounted for. I want to find everything over here, but I still have to pull out everything on the left side. Well, the nice thing with this is a normally distributed graph, or data that has been normally distributed, is perfectly symmetric. So if I know I have 32% left, and I have an equal amount on both sides of my graph that I haven't accounted for, I just need to divide that 32 in half to figure out what each side is. 32 divided by 2 gives me 16. So from here over is 16%, and from here over is 16%. Well, that's all I needed. I just needed to know what percent of scores were higher than 87. So 16% right here. That's my answer for this problem.